All right, let's take a look at the mean volume theorem. I kind of wrote it down and then I'll kind of talk you through it. So this is what it really says. The formula is f prime of c equals f of b minus f of a over b minus a. Well, let's take a look what all those mean. F prime of c is just the derivative or the slope at c. And then this side, f of b minus f of a is a delta y. It's the difference between y values over the difference between x values. Right, delta y over delta x, that's just average slope. And I say average because it's the slope over an interval. And what the mean volume theorem says, it guarantees that there exists a c, meaning an x value, such that the instantaneous slope equals the average slope as long as, if, big key, if we know that f is differentiable on the interval a, b. Okay, I'm going to give you a really quick example of when it wouldn't work. I could take something like this. I could take two x values, a and b. Let's pick that one and that one. If you found the average slope between those 2 points, it'd be this. Well, is the average slope equal to the instantaneous slope at some point c? And you'd never be able to find the c. The average slope here would be 0. But there is no x value such that the instantaneous slope is 0. Well, why? Well, because f is not differentiable on AB. The derivative doesn't exist at this point. Again, the mean volume theorem doesn't apply. Does not apply over the interval I looked at. Again, it has to be differentiable. Okay, so let's assume it's differentiable. Then the mean volume theorem says there must exist some c, some x value, such that we can find where the instantaneous slope equals the average slope. Okay, let's go through an example of one that does. So let's look at y equals x cubed plus 1. Okay, that's a nice easy function to kind of take a look at. Let's look at this interval here. When x is 0, it's 1, and it does something like that. Okay, so let's look at 2 points. This is the point, what is this? 0, 1, and 2, 9. Okay, so those are my points. Clearly this is differentiable on this, right? It's nice and continuous, and the left slope and the right slope are the same, and we know that polynomials are always differentiable. And so what we're saying is, there's the average slope. That's this side, f of b minus f of a over b minus a, and then let's find that slope. Okay, so the average slope m is just 9 minus 1 over 2 minus 0. Okay, and that's just 4, right? That's the average slope. Okay, and then if we want to say, well, what does the mean volume theorem says? It says that it guarantees there's an existence of some c value that where the instantaneous derivative equals the average derivative. Okay, so let's find the derivative. The derivative, y prime, is 3x squared. And so we're saying ourselves, when on this interval does 3x squared equal to 4? That's really what I'm saying here. When does the derivative equal the average slope? Well, here's the derivative. Here's the average slope. When do they equal? And we say x equals 4/3 square root. Otherwise, we could say this. And if we want to get silly, we can certainly say that this is 2 radical 3 over 3. Okay, this is our c value. At that c value, we're saying that the derivative, meaning if we go to this value, let's say on the picture it's right there, that the instantaneous slope at this point is equal to the average slope. And if you look at this, what we're claiming is that the tangent line and the secant line are parallel. That's another way to look at this. The tangent line has the same slope as that at that point, is parallel to the secant line, and the secant line is just the line connecting the 2 points. Okay, and that's really all the mean volume theorem says.